Hi, this is Shale. I'm here to talk about the environmental impacts of shale gas development in China. So shale gas is considered as an unconventional gas resource. China has already included shale gas in its national energy strategy, while large-scale commercial development is yet to start. Due to its low productivity and high scattered nature, shale gas development is much more complicated than conventional gas. Given the special geological and ecological characteristics of southwestern and northern China, where shale gas is abundant, the environmental impacts are summarized as ecological impacts, underwater pollution, greenhouse gas emission, and so on. So, like I said, due to its low productivity and high scattered nature, shale gas development is much more complicated than conventional gas. So special environmental characteristics in China's shale gas favorable zone will worsen the potential risk of environmental pollution and ecological destruction. Here are the three major types of environmental impacts of shale gas development in China. The first one is prominent land occupation and ecological impacts caused by large numbers of wells. The second one is water resources and water contamination issues caused by high water consumption. And the third one is impacts on air quality and climate change. So for the first one, shale gas resources spread over extensive areas with low concentration of gas per unit area. So as a result, a large number of wells have to be drilled to obtain commercial quantities. In addition, the access roads, water channels, and gas gathering pipelines will require a large area of land as well. Therefore, attention should be paid to land occupation and surface turbulence issues resulting from well drillings, as well as to providing ecological protection. Further, competition between shale gas development and agriculture, ecology, and local land usage should be considered. So the second one, water resources and water contamination issues caused by high water consumption. The development of a shale gas project mainly includes exploration, drilling, and water completion. The key technologies are horizontal drilling and hydraulic fracking. Fracking is a highly water-intense process. Even with a high flowback rate, its water consumption can be 10 times more of that of conventional gas production. This will constrain shale gas development in water-scarce area and affect sustainable consumption of local water resources. Wastewater generated during shale gas development contains more than 100 types of chemicals such as hydrocarbons, heavy metal, and some radioactive substance. Deficiencies in the water injection process or injection formation selection will result in groundwater contamination. In China, most of the favorable shale gas fields are located in Sichuan, Chongqing, Hunan, and Guangzhou provinces. The complicated geological conditions in these areas increase the difficulties concerning groundwater contamination, prevention, and control. The third one, impacts on air quality and climate change. Natural gas is a major resource of anthropogenic methane emission, VOCs, and other air pollutants. The shale gas reservoirs in China also contain hazardous levels of more than 1% of H2S, which is hydrogen sulfur. Inappropriate collection and treatment of these pollutants will affect the local air quality. Compared with conventional gas, the development of shale gas has a higher risk of greenhouse gas, especially methane release. Given the high population density in southwestern China, the impacts of air pollution and climate change should not be neglected. So, according to my research, here's some solutions and or recommendations to solve these pollutions or these impacts. Carry forward the strategic EIA, which stands for Environmental Impact Assessment, and Planning EIA. Optimize the development plan and time sequence from both resource development and environmental protection perspectives. Collect existing information on the distribution of shale gas resources and conduct strategic EIAs. Categorize the resources from the perspective of environmental protections. Identify areas where are not favorable for development. Optimize the planning for shale gas development from the perspective of resources efficiency and environmental efficiency, ecological and environmental loads, and level of environmental risks. Take into consideration regional environmental characteristics. Categorize and optimize the shale gas development time sequence from the perspectives of both environmental protection and risk management. And here are the references. Thank you.